Hello, this is Mr. Collier, and today we're doing some compound interest problems. So here's a formula for compound interest, including if the interest is compounded during a certain time period. So if it's compounded monthly, that means 12 times per year, then you put in 12 for the K. Or if it's compounded daily, then you put in 365 for K. So there's the formula. It looks kind of complicated, but it's really just plugging in values. So we're going to use formula now to do example 1 where Ahmed invests 4,000 Malaysian ringgits. That's the present value or the original value. In a bank offering interest at 5% per annum. So that's your R. And it's compounded quarterly, which means 4 times a year. So your K is 4. So calculate the amount of money that Ahmed made in the bank after 6 years. So that's your N equals 6 after 6 years. So let's write down the formula again. So the future value equals the present value times 1 plus R out of 100 times K power of Kn. Okay, this R divided by 100, that just changed the 5% to 0.05. That's why that 100 is in there. So we'll just substitute in all the values. We have 4,000 for present value. We have 1 plus R, which is 5 out of 1,000 times 4. And here we have 4 times 6 because it's 6 years. Let me simplify it a bit, and then I'm just going to type it into the calculator. So this is 1 plus 5 out of 400 to the power of 24. So if I type that into my calculator, then I should get the correct answer for the amount of money he makes in 6 years. So we have 4,000 times, in brackets, 1 plus 5 divided by 400 to the power of 24. So I type that in, press enter. I get about $5,389.40. So 5389.40. 5389.40 and Malaysian ringgits. Okay, so that's your future value in 6 years. Now part B says how long does it take for his money to double. So that's the doubling time. That's very important. Investors are very interested in that kind of thing. So how long will it take his investment to double? We started off with 4,000, so it doubles when the amount is 8,000. So 8,000, when does 8,000 equal 4,000 times 1 plus 5 out of 400? And the year is not 6 now, we don't know the year, so this is going to be 4 times the number of years, which is n. So that's the formula we use, and we got to solve for n. What we're going to do is we're going to type into our calculator this function, and then calculate the number of years it takes to reach 8,000. So we're going to type this into our calculator and use a table. So we're going to type that in now, 4,000 times 1 plus 5 divided by 400. Power of, now be very careful here, you have to put that 4x in brackets. I made a mistake earlier and didn't do that, and I got all the wrong answers. So that has to be in brackets. And then second function graph. And there we have all the values, and we want to go down until we see 8,000. So after 14 years, the amount in the bank is about 8,000. So the doubling time is about 14 years. Okay, so maybe we can say by GDC, doubling time is 14 years. Okay, let's take a look at another example. It's estimated that the value of a lump sum investment is 7% more than its value in the previous year. Estimate the number of years it will take for the investment to double. So we're only given the 7%, and we want to figure out how long it takes to double. It's very doable. Let's take a look at this formula. Future value equals present value times 1 plus r out of 100k power of kn. Okay, there's no mention of compounding monthly or anything like that, so we can assume k equals 1. And 1 times 100 is just 100. 1 times n is just n, so that pretty much just write the formula without the k in it. So we don't know the present value or the initial value. And we know r is 7, so we have 7 out of 100, and the k is 1, and then we have n here. Alright, so we're looking for the doubling time. So the present value is 1,000. We're calculating the time it takes to reach 2,000. If the present value is 500, we're looking for the time it takes to reach 1,000. So it really doesn't matter. We can stick in any value we want for present value and work it out. So let's say I like to pick an easy number like 100 or 1,000. So we're going to find out when does 2,000 equal 1,000 times 1 plus 7 out of 100 to the power of n. Using our calculator, we're going to type in the function y equals 1,000 times 1 plus 7 out of 100 to the power of x. And we're going to use our calculator to calculate that for us. So we're going to put in the function 1,000 times 1 plus 7 divided by 100 to the power of x. Type that in, second function graph. And when will that equal 2,000? Well, it equals 2,000 after 11 years. So 11 years is the doubling time. So we can say maybe by DEC, doubling time is 11 years. Okay, let's take a look at the next example. Lena paid $32,000 US for a new car. The car depreciates at a rate of 10% per year. So depreciates means goes down in value. Find the value of the car after 5 years. So let's take a look at the formula. FV, or future value equals present value, times 1 plus r out of 100k, power of kn, and again, there's no mention of compounding monthly or anything, so k is 1, and we have all the other information we need. So the present value is 32,000. Then we have 1 plus, actually in this case, this is depreciation. The rate of interest is negative 10%. So here we're going to have, oops. So here instead of plus, we're going to have minus 10 out of 100 to the power of n, which is 5 in this case. Okay, so it's depreciation. You got to subtract the rate of interest. So we're just going to type that into the calculator. We're going to have 32,000 times 1 minus 10 out of 100 to the power of 5. That gives us 18,895, 68. 18,895, 68. And that's US dollars.